Welcome back, everybody. In this section, we will answer the question, what makes coastlines look the way they do, and what are the different features? So we've made it to the last item here. We're going to discuss the mechanisms through which the oceans shape the continents, as well as the resulting landforms. Now, the type of landforms that we're going to get depends entirely on whether we are at an active or passive margin, whether we have dominantly erosional landforms taking material away, like we see in the picture here, eroding the rock down, or other characteristic landforms which are caused by deposition on the more passive coastal margins. So we have active margins with erosion, passive margins with deposition. Okay. Now, we'll start with these erosional landforms, active margin settings. We're going to be closer to plate boundaries, closer to the leading edge of the plate. We're going to have high relief, rugged topography. We're going to have a lot of exposed bedrock, steep slopes, high elevation. This that we see in the picture is very, very typical of what you'll see in these settings. The rate of shoreline retreat, so up the shore moving backwards, tends to be slow because we have such rugged terrain. It tends to be a very, very slow process of actually eroding it back. And the type examples are going to be the west coast of North and South America. So this diagram has everything that we'll be talking about in more detail here. So we have our erosional setting, rough topography. There are these things called wave-cut platforms, and we won't worry about the wave-cut, we'll worry about the platform. You know, it's kind of a broad, flat platform here down below the cliff. We have things called blowholes. You might imagine that there's a hole here, tide comes in, or waves come in and washes up through there where the ground is actually eroded away. We have these sort of insulated bodies, right, bays, which are sites of deposition here. We can see it builds up a beach. We have the more exposed headlands, and these headlands get battered by waves, tend to be a site of a lot of erosion. We have the sea caves, little inlets, or a natural bridge if the sea cave works its way all the way to the other side. And we might have a series of headland bodies that have been cut off from the main landform known as sea stacks. Okay, so we'll look at a few images here, real places in the world, what they look like. And you can see there is some deposition here, a beach on the inside. This is the feature we're looking at. We have some deposition here on the beach, on the inside of this feature here. And there's sort of a narrower inlet opening up into this larger inland body of water. I have sort of a narrow inlet here opening up into this body of water here. This is going to be a bay. So we have our broad inlet of the sea. The land curves inward, right? Inward curve of the land, and directly connects with some larger body of water. The bay does, so it's connected to the ocean. And here is another feature we looked at, this thing called a wave-cut platform, and the key to it is in the name. So originally, the cliff would have been all the way out here, and the waves come in and wash up and start to erode away the underside of the cliff faster than the upper part of it, which would have been sheltered from the water. So it erodes the underside of the cliff, but not the upper part, until the upper part topples down. And this process continues as it cuts inward, leaving behind this broad flat area on the edge. And we can actually look here at the process in a little bit more detail. So here is our water, and this is actually the platform here. This is our cliff. So originally the cliff was all the way out here. Water comes in and removes the underpinning, the foundation of the cliff, until the top part falls off. And then this repeats, right? It comes in, it erodes the underside until it falls off. So the cliff is slowly retreating backwards and leaving this broader, flatter area, the wave-cut platform, in its wake. So we have our definition here, a narrow, flat area often found at the base of a sea cliff or along the shoreline, going to be our wave-cut platform. So what are we looking at in the two images here? Well, it looks like a piece of the land is just jutting out into the sea, right, ahead of everything else. Here we have, okay, something that looks like maybe a beach and a bay over here, but really we're looking for this feature like we see in the other one. Something that's sort of jutting out into the sea. Well, these are going to be sites of preferential erosion. They're called headlands. We have a narrow piece of land that projects from the coastline into the sea. Now, what do we see here? We're focused on this feature, image that should look a little bit familiar to you, maybe. We have this main landmass over here. And at one point, it would have jutted all the way out here, right? Jutted all the way out like a cliff. But somehow the water has managed to eat through all of this, right? Maybe it formed a cave at some point, and then it ate more and more, and there was collapse of some of the stuff up above. Maybe that stuff was a little bit less resistant to erosion compared to the stuff around it. And as a result, we have this sort of natural bridge, which is connecting these two land masses. And this is called a natural bridge. We have a natural arch where a coastal cliff or a headland is subject to weathering and erosion, but it doesn't collapse completely. Now, if we go back, right, we can also see another feature here. So You imagine this natural bridge were to erode completely away, in which case we would have our main body here, and then we would have this stack of rock out in the sea that looks maybe like this one. And as you would expect, this is called a sea stack. So this is our column of rock in the sea near a coast, but it has been separated somehow from the main shoreline or headland. And the process which creates the natural bridge, running over more and more time, will eventually make the sea stack. So that is going to finish out our section on active margin erosional landforms. Now we'll look at the opposite. We have our depositional landforms. So instead of taking material away, like we saw, we're going to be putting material in and building it. So these are passive margin settings, tend to be far away from the plate boundaries. We're going to get lower relief, wide coastal plains. We have many, many different sediment types that are transported and accumulated here. We can get erosion in certain places and deposition in others, dependent on several factors. Mostly, we're looking at depositional features here, and our type examples are going to be in the Atlantic and Gulf coast of the United States. So there are two key processes involved here as it relates to our beaches and the movement of sediment along the beach. So we can talk about this smaller idea of beach drift. We have our movement of sand along the shoreline due to wave action, to where the beach is present in one place, and as the waves come in and work it and rework it, it starts to move. And this is part of the bigger picture of longshore drift, which affects not just the beach, but the entire area. And here's what you might imagine, right? We have waves which come in at an angle to the shoreline. So they come in here, the wave comes up, but then when it washes back out, it doesn't wash back out at an angle, it washes back out as fast as possible. It comes here, perpendicular to the shoreline. So then it comes in at an angle, and comes back out perpendicular, comes in at an angle, comes back out perpendicular. And the result of this happening over and over is it's going to start to move the whole beach in this direction, depending, of course, on factors like, well, what angle are the waves coming in at? And so by the accumulation of these longshore drift and beach drift processes, we can have these landforms, which we'll see, that take a beach and then extend it out in a certain direction. And if we go backwards, we go the other direction, we can look at these landforms and tell what the drift direction is, what the wind and the tides and the currents are actually doing in that area. So this is our overview with all the landforms we're going to be talking about. Our longshore current direction is this way. So just like we talked about, that is going to extend the beach outward here, make something called a sand spit. As a result of this and some other process, we have this choked off inlet which leads to a bay. We have this sort of barrier island here, just like this one over here, that sort of protects this body of water from circulation, leads to a lagoon. We can have something that is called a bay mouth bar, a bar just being a pile of sand or sediment here, and because it's out the mouth of the bay, we call it a bay mouth bar. And we have our beaches, of course, as everybody knows. We have these features called sea islands and then tombalos that tend to connect them. So how do these form? So this is the first feature we'll look at here. We have our beach here at our coastline, but it looks like somebody took the beach and sort of extended it downward, right? You can imagine we have this longshore drift, so it brings sediment in, and comes back, and then brings sediment in, and brings back, brings sediment in, and comes back to where it's moving the beach slowly in this direction, right? Almost like a curved tip or hook off the coast. And you can see the same thing happening here. These can be considerable in terms of size, right? These are boats. It's enough to create a whole harbor here, at least a small one. So these are going to be called spits, right? We have our extended stretch of beach material projects out to sea from the mainland and is joined to the mainland at one end. Okay, so what about these images here? Well, it looks like we have our narrow inlet connecting a smaller body of water to a bigger body of water here. We have our narrow inlet connecting a small body of water to a bigger body of water here. We could conclude that these are bays. But the difference between these bays and the erosional bays that we looked at earlier is going to be, well, the deposition as our key feature. So we might imagine that there is this building sediment pile here which restricts access between this water and the water in the bay, right? In other words, it's a building process as opposed to the erosional process that we looked at before. And as a result, the water here might be much more cut off from everything going on in the ocean. So we have our bay mouth bars, which are going to be these sediment piles built up, and the result is a bay, right? A sandbank that partially or completely closes access to a bay. Okay, now what about these images? Well, I can spot some kind of a landmass in the background here, and there's this long, narrow island here that seems to be cutting off this body of water here, but maybe going parallel to the landmass, right? So we have our greater landmass in the background, and we have this long, narrow island here. So these are actually going to be called barrier islands. We have elongated islands of unconsolidated sediments, so not hard rock like sandstone or something, but usually loose sand. And the trend of these is going to be parallel to the shore. In other words, we know that the shoreline is running this way in both of the images here. Now, what are we looking at here? Well, we have these piles of sand which trend parallel to the shoreline. And if we have our passive margin setting, we can expect the beaches to be much bigger, right? Flat, broad beaches when compared to the active margin coastline settings, right? So we have our narrow, gently sloping strip of land that lies along the edge of an ocean, lake, or river. You know, a beach. And this is the final feature that we'll look at. You see, we have these sea islands, right? Sea island here and a sea island here. But what we're focused on is this narrow strip of sediment that seems to be connecting them, right? And our narrow strip of sediment here. So this is a tombalo. We have a bar of sand, a pile of sand, which joins some kind of island to the mainland. So what are our big ideas as it relates to coastal geology? Well, coastlines first. What are they, and who has the most, and why do they have the most, and maybe a little bit about that interesting coastline problem. What is the difference between an active and passive margin? What are currents, and how do the global currents come together? Why are they in the pattern that they are? What are the controls on this? We talked about tides, specifically spring and neap tides. Could you identify these? Could you explain how they are related to different phases of the moon? Things like the perigee and apogee, perihelion and aphelion. What causes tides in the first place? Finally, we talked about erosional and depositional coasts and our coastal landforms. That is all I have for you. For those of you who made it to the end, thank you.